Hello friends, for the last few days I've been playing around with this topology for CGNAT or carrier grade network address translation. And the way that works, as you see here, so we have some subscribers that are coming off of these routers that are coming from the provider. And this could be very relevant to either a cell phone network or also a Starlink network, right? Because they're both operating on CGNAT. The way we're operating here is that these devices are getting an IP address on these specific networks. And in order for this device to access out of the network, they will have to reach from here to here. And then there is a different network that gets translated here. This 10 network, which it goes up and gets NATed again between the outside network and the inside network. Same thing happens here. This will become the outside network and this will become the inside network, thus the double NATing. All right, so as NATing, as we know, typically in homes, we use it so that we can always access the internet, but the internet cannot access the devices inside the network. And the same is true here. The only difference that I have here is that I have tunnels created between all of these routers here, allowing me to connect between these individual networks because that's the way I want it. So we have subscriber 1 over here, which is 1.10, and then we have subscriber 5, which is down here. It's 5.10. So if we were to ping between these guys here, pings are successful, and if we were to do a trace route, we will be able to see that we're going from subscriber 1 to the default gateway, which is 1.1, and then it's going to reach into the tunnel, which is demonstrated here with 172.16.0.11, and that's going to make it across so that they can actually ping each other from site to site. All right, this is just because this is the way I want it. That's the purpose of this lab for me. Now, let's see what happens when we try to reach outside of the network from site 1 to that remote network, router 1.230.109, that one. So that ping successful, that is going out. Now let's see going from this router on the outside of the network, trying to reach inside of our double NATed network here, 110. And that obviously is not working, which is the appropriate way for it, right? The reason for it is because there is double NATing here and then NATing here again. So we don't want traffic from the outside coming in. The traffic that we want is from the inside of the network going out, right? And this is accomplished through NATing rather than routing on the way out. Okay, so the same thing here. This is 5. 5 can ping 1.10, 0.109.1. It can also ping the remote router. And let's see the other way around. Perfect. So not able to come out. Now let's do a trace route from the inside of the network to see how it looks going out. Trace route 203.0.109.1. And let's do the same thing from this side. Trace route 192.510. All right, so on the subscriber side, we have that we go into the gateway. That gateway goes into the 10 network, and then it reaches out to 113.1, 112, and that reaches out down into this network here. And these networks up here are doing BGP and OSPF, and there is some other fancy stuff that's going on this side too. So let's see what this guy has to say. So we got some BGPs going on in there. We got some static routes. And then on this side, it's just playing around with some distributions. Thought it was appropriate. Here we go. Here we got some BGP, some OSPFs, and some other BGPs. And then we see how those are reflected on this side. If we do a show IP route, we can see the externals that are brought in from OSPF and from BGP into OSPF. Perfect, beautiful, beautiful. And of course, the snatting portion up here on this side right here was great work too. Let's see how those routes look like. Yeah, so we got some EIGRPs going on in there. Right, and then we got the static route on the way out. Perfect. But that was it. I just wanted to show you this cool lab for double natting. And again, this is something that it's functional, whether you're using CGNAT with Starlink or you're using CGNAT with your cell phone provider, which typically does the same thing. Where their IP addresses, the IP addresses provided to us are not really private IPs. They're just IPs inside the carrier network that are natted on the way out. Well, I hope you enjoy this lab as much as I did. I catch you on the next one.